This is the Algebra 2, Unit 3, Test Review Guide Answer Key video. So the first section of this test is going to be quadratic applications or quadratic problem solving. These are the problems where you don't enter your data into a table. You're going to be given an equation for the problems that you enter into Desmos, and then you observe what's going on in the graph and answer the questions about the graph. What I would recommend that you do is pay close attention to what value is being graphed on the x-axis and what value is being graphed on the y-axis. The x values are not always going to be given as x's. Often they'll be given as t's for time, and the y values won't always be given as y. Sometimes they'll be h for height or other values. Keep in mind what you've learned in science class about independent and dependent variables, where your x is always your independent and your y is always your dependent. When you answer your questions, if it says something about maximum height, but the input in that problem is time, then you want to probably look at your y-axis to find the height. So let me start with problem number 1. So in problem number 1, you are given an object that's going to be thrown into the air, and the y-axis is going to be giving you the height of the object, and the x-axis is going to be giving you the time in seconds. Your height, by the way, is given in feet. And so the first thing that you want to do is take a look at the equation, and you want to type that into Desmos. You can either type y equals or not. So on the example or the sample graphs that I'm going to give you, I'm just going to enter the stuff after the equal sign and not the y equals. So when I've entered this equation into Desmos, what I see is this graph here, and I want to pay close attention to the x-intercepts, the y-intercepts, and the maximum or minimum. And so in this case, you'll see that the y-intercept, this value right here, your y-intercept, is 10. There's an x-intercept that you don't need to worry about. So this x-intercept, this negative x-intercept over here, you don't need to worry about, because your x value in this problem, as we said, is time, and we're not going to ask you questions, at least at this level, about negative time values, and so we only care about the positive values. So for now, we care about this y-intercept, this x-intercept that's positive, and the maximum value. After you have looked at the graph in Desmos and kind of have a feel for what's going on there, then you want to make a sketch of that graph on your paper. So I'm going to give you a little bit of a axis system. It's not anything fancy, and you just kind of want to give me an idea of what the graph looks like in your Desmos. Notice, and I want you to be a little bit particular in approximately where the intercepts are and where the max or min is. Don't just do that, okay? You kind of want to give me a feel for the fact that there is a y-intercept that's positive, and that it's a maximum, not a minimum, and that the x-axis or the x-intercept that you're interested in is to the right. So I'm going to erase what I drew in red here because that's the wrong one. And then you just want to label the intercepts and the max or min. So here I'm going to give myself a dot and say that the y-intercept is 0, 10. I'm going to say that the maximum, and again, give me about 2 decimal places if there are 2. So here the x value is 9.5, the y value is 190.5, And then the y, or the x-intercept over here is 19.26 and 0. And so your graph for now is going to look more or less like this. And so here I ask you some questions, and the first question is, how long has the object traveled? How long, meaning in time, has the object traveled when it reaches its maximum height? So notice that you've got the word maximum in there, in that question, and so I would be looking at the maximum on the graph. And then I want to ask myself, well, what do those values represent? And remember that your x value is time, and your y value is height, and the question says, how long has the object traveled in time when it reaches its maximum height? Well, that maximum height is 190.5, but that's not what we're asking. We're asking for how long has it traveled. It has traveled 9.5 seconds. Please remember to put labels on your answers, seconds or feet or whatever that label is. The next question asks, what is the maximum height? So that's where you're going to pull in that 190.5. Again, we're looking at that maximum point. And this time it is asking what is that maximum height. So here's where you'll use the 190.5. Now the next question asks you if the object was launched from ground level. Well, launched means when it starts its motion. So here, let me switch colors. The idea of it being launched, or when it starts, is going to be when time is 0. And time is 0 at the y-axis. So that's this point, this y-intercept. And it asks if it was launched from ground level. And if you think about this, ground level is when the height equals 0. So ground level is if the height equals 0, you're looking for a y value that is 0, and that y-intercept here, the y value is 10. So the object was launched from 10 feet. So technically, your answer for this question would be no, it was not launched from ground level, and then you can justify that by saying it was launched from 10 feet off the ground. Now, the next question asks for the height after 2 seconds. And there's been some discussion in class about that word after. That's just an English quirk. At 2 seconds, how high is the object? That's really what it's asking for. Well, 2 seconds is an x value. So it's saying when x equals 2, what is y? That's really what this question is asking. What is the height, y, of the object when x equals 2 seconds? And so here, I've done a different graph. If your x value is 2, you can substitute 2 into all of the x's in the equation, and that's going to give you 78. There's no real other way to do that by manipulating the graph. So I'm just going to substitute 2 into the equation, and that gives me the computation 78. Remember to use 78 feet. Question F asks when it hits the ground. So the object has been traveling for a time, and then it hits the ground. And hits the ground is always going to be, when you're talking about a y-axis that's height, the ground is always y equals 0. We said that in part C. And so here, I want to look for where the object hits the ground. I'm going to come back to my first graph, and that spot where the object hits the ground is going to be here. It's going to be that x-intercept after this many seconds. Your y value here is equal to 0. And so it's going to be 19.26 seconds. And then the last part of number 1 asks after how many seconds, or at what time, at x equals what time, is the object 100 feet from the ground. Well, to do that, you want to give yourself an idea of where 100 is on the graph. So here, if this is 200, this would be 100, right? And so you want to look across here, and it says on the descent, meaning as the object is coming down, you want to know how many seconds this is. You're looking specifically at this spot on the graph, 100 feet from the ground. You want to know what that x value is. And so what you want to do then is graph that line that I just drew, that horizontal line. You want to actually make Desmos graph that and find a specific answer. And so here is what it would look like. You're going to type in y equals 100, and that's going to give you that horizontal line graphed across your graph. And you'll see that the time specifically to 2 decimal places that the object is 100 feet off the ground on its descent is 16.227 seconds, or 16.23 if you round to 2 decimal places. In this next problem, number 2, you've got a situation where you're launching a water balloon into the air. And so the equation that represents the situation is given here as h equals negative 4.9 t squared plus 27t plus 2.4. And so what you want to look at in this equation is that your inputs are t's, and in Desmos you're going to type those as x's. Your output is h, and that's what you're thinking about as your y value or your y-axis. So when you type all of this into Desmos, remember that you're going to use x instead of t, and here's the graph that you get. And you want to just click on the y-intercept, which gives you 0 and 2.4, the maximum, which gives you those values, and the positive x-intercept. And here, again, you're talking about a problem that has to do with time, and so on your x-axis, we're not going to worry about negative values of time. So I'm going to copy this graph onto the axes that are on the paper. I am going to label the y-intercept, the x-intercepts, and the maximum value. The y-intercept is 0 and 2.4. And the maximum here is, and here's where I would recommend rounding to 2 decimal places. So it's 2.755, I'm going to round it to 2.76, and it's 39.594, I'm going to round it to 39.59. And then this x-intercept here is 5, it says 5.598, I'm going to round this to 5.60 and 0. Now, the thing that I think I forgot to do in problem 1 that I'd like you to do is label the axes as well. So your x-axis, remember, is going to be time given in seconds, and your y-axis is going to be height given in meters. And that just helps you keep in mind what values you're looking at and when. So the first question asks you to give how high. So your answer, how high, that's going to be a y value. Y equals what after 1 second? Well, remember that your x values are your time. And so you want to know when x equals 1, what is your y value? Because 1 second isn't any of our main x values that we labeled on the graph over here, when I say that, I mean that if you look at the x values, x equals 1 isn't any of these numbers, and it would be somewhere around here. And so I can enter 1 into that equation like this in Desmos. I have the equation already in the first slot. I'm going to retype it so that the x's are 1s, and that should give me 24.5. And remember that the label here in this problem for the height is meters. So 24.5 meters. The next question asks for how long. Well, that's a time. For how long is going to be an x value. It's asking x equals what? Is the balloon more than 30 meters high? So for how long is the balloon more than 30 meters high, and 30 meters is a y value. So this is another situation where you want to have Desmos draw a line, a horizontal line at y equals 30, because you want to find out about this time in between. You want to find out how long was it above 30 meters. So I'm going to do y equals 30 in the next line so that I graph that horizontal line. So if I type in y equals 30, it will graph a horizontal line for me that goes from the x value 1.3 to the x value 4.1. And all the time in between, that's all the time that the balloon is above 30 meters. So I would subtract that 4.15 minus that 1.36, and I can do that in Desmos. I don't have a screenshot of it, and you should get 2.79. So for 2.79 seconds, that's this, the balloon is higher than 30 meters. Then it asks what is the maximum height of the balloon, and that's where I'm going to go back to the maximum in the graph here. Remember that your y value is the height, and so that maximum height is the 39.59 meters. And finally, it asks, when will the balloon burst as it hits the ground? Because, you know, that's the whole fun of a water balloon. That means when is talking about the time So that when it hits the ground, remember that the ground is always height equals 0. So the height is 0 at 5.598 seconds, or 5.5 or 5.60 seconds. So at 5.60 seconds after launching the balloon, it will burst when it hits the ground. Now, the second section of your test is going to be the regression section. Remember that regression is when you are going to type in the values into a table, and the table will plot points on the graph, and then you're going to force Desmos to give you an equation that best represents those points, the pattern of those points. So what we'll do is we'll start with just some x and y values, and this should be the most straightforward part, where I give you, for example, in number 3 points, and remember that in any point, your first value is an x, your second value is a y, and so I'm going to take the 3x values and put those in a table and make them correspond with each of the 3y values. So where x is -1, immediately next to it on the table is going to be -12. So I did a screenshot of what that should look like. And what I do is I start here in the second line of Desmos, and I type in my x and y values from those points. -1, -12, 2, -6, 4, -12. And if you can't see the points in Desmos, then you can click on this little magnifying glass and it'll zoom Desmos to where those points are. You have to type them in first, and then the magnifying glass will zoom to fit whatever your table is. Then I go back up to the first line and I type this. And remember that that tilde, or that curly thing next to the y, that is shift, and then the key is next to the 1 key, and it looks like this, and it's next to the 1 key. On the left side of your keyboard. When you want the subscripts, meaning y1 and x1, you just type y and then 1, and Desmos automatically makes it a subscript. The other thing that I want to point out is that you need to double check, especially if this isn't your first graph and you haven't refreshed Desmos, that the x1 and y1 in your table have to match the x1 and y1s in your equations. And if they don't, you can change them. I would change the ones in the table because there's fewer of them. But if your table says x2 and y2, then your equation has to say y2 and x2. So once you've got all that set up and you can see the graph of the parabola in Desmos, and you've got your table all set, the next thing that you want to look at is these 3 values, a, b, and c. And when you write your equation, you're going to correspond a, b, and c to the coefficients in your quadratic equation. And that's it. That's your answer. So what you're going to write then on your paper here, when I ask you what's the regression model or what's the regression equation, here you're going to say y equals, don't say y1, just say y equals, and then a was -1, so you want -1 x squared, you don't need to write the 1, plus bx, so that's going to be plus 3x, and then plus c. Well, c is -8, so I'm going to write just -8. And that's your answer for number 3. So now, number 4, I won't say as much about. Number 4 gives you those 3 points. Your graph for number 4 should look like this. This is number 4. And you're going to look at these values for A, B, and C. And then number 5, I've got over here. Again, you want to look at these values for your A, B, and C. And your equation should be y equals 5.5 x squared minus 23.5 x. Looks like I'm going to run out of room. Plus 29. So the next question, the next two questions actually, we give you a scenario, just a real life situation, and you are going to use the regression data given in a table to create a regression equation or a regression model, and then we'll ask you some questions about that equation. The questions themselves should feel a lot like the first part of the test, where you're finding a height or a time in seconds or something about the graph you just drew. So the only difference is that we're adding some steps to the beginning of your process where you actually have to type into a table and generate the equation that you're going to be using. So in this situation, there's a tower in Toronto that that is pretty famous. And if you go to the top of this tower and you're wondering about what if you drop something from the top of the tower, so you decide to drop a penny from the top of the tower, and let's say that you can measure how high the penny is off of the ground after a certain amount of time. So you're given this table. 0 would represent when you dropped the penny. As it gets closer and closer to the ground, your y values represent how high off the ground it is. So it would make sense, I hope, that the distance from the ground is getting smaller as the penny drops toward the ground. And so your process for this is the same as your process for entering the tables in the previous 3 questions, where you would go, and I like to clear Desmos completely in between, like just refresh the screen so that I don't get that x2, y2 stuff going on. But here's what your screen would look like then. I entered the values from the table into the second line on Desmos, and then I type this regression equation, and I will give you that regression equation on the test. It's also on this page of the review guide, but I'll also give it to you on the test. You don't need to remember that, and it's going to be on the board in my classroom. It's already there. You've been looking at it in class, and it's not going to go anywhere between now and when you take your test. So I would type that equation into the first column, and then here is the equation that or the A, B, and C values that you're going to use as your coefficients. And I literally just noticed that the B value is in scientific notation. So let's I'll modify that, but there won't be any questions with that problem, with that issue on the test. Just FYI, so you don't have to worry about the problem that I'm talking about here is in letter B. That's a wonky number. So we'll just kind of modify that as we go here. In fact, let's just make that 0. I'll make an executive decision now, make B equal to 0, and that way when we write the equation, we won't have an X term. So the first question here asks you to give the equation that models that data. And if you think about it, the penny that you drop from the top of the tower, as gravity really takes over the situation, the penny's going to start to go faster and faster toward the ground. And so that represents a quadratic relationship. And the equation that we have is going to be, and I've given you here the y equals, but if I don't give you y equals, make sure you write y equals. And then your a value is minus 16, and then it's going to be x squared. And then we made b 0. You can put plus 0x, or you just don't write the x term. And then c is plus 1821. And so that's your regression equation. And then it asks what distance the penny is from the ground after 5 seconds. You can type 5 into the equation in Desmos and compute an exact amount, or if you take your cursor and actually hold it down on top of the graph. And it's hard to show because I'm not holding my cursor in this video, but if you kind of drag, I'll show you with a highlighter, you can kind of drag your cursor along top of a graph, and when you're watching the x and y values kind of very slowly approach x equals 5, and what you'll see is that if you kind of go back and forth just a tiny bit, you should be able to see what the y value is when x equals 5, and that here is going to be 1,421. And so my answer then to that question, when the time is 5, or after 5 seconds, you're going to be 1,421 feet off the ground. C asks, after how many seconds is the penny 50 feet from the ground? And that's, remember that your y values are your height, so that means y equals 50, and that's going to be one of the problems where you make Desmos graph a horizontal line. And again, my software is being wonky. Here we go. So I typed y equals 50 in the next line. That gave me a horizontal line on my graph. And that means here that y equals 50. My answer, though, is the x value, 10.521. And I'm looking at my answer here. So 10.521 seconds then is going to be the answer to that question. 10.52 is all you have to write, and remember that it's seconds. And as always, hitting the ground is going to be your x-intercept when the height equals 0. Remember that that's the x-intercept when height or your y value equals 0. And so that's going to be back at my initial graph. That's going to be this point right here, which I didn't click on before I did my screenshot, but I'll give you those values right now. This point right here, the x-intercept is 10.6680. And so I'm going to give my answer as 10.69 seconds. So in number 7, we're talking about a store that, or a sporting goods store or something that sells skis, snow skis, and they're trying to keep track of their stock and how many skis they sell at different times of the year. And so you would assume that coming up to or getting into the winter that there would be more skis sold, but nobody's really thinking about buying snow skis in July, so they probably sell fewer skis in the summer. So they give you this table, and they tell you specifically to number the months. January is month 1, February is month 2. So what I'm going to do before I even type any of this into Desmos is I'm just going to come over here and say 1, and then March is 3, and May is 5, and August is 8, September 8, September is 9, and December is 12. And so those are the numbers then that I'll type in to my X values, which are represented by T, and the number of skis sold is going to be my Y values, or my dependent axis. So when I type all that into Desmos, I get this graph here. These are those values, and then this is my A, B, and C that I want to use to write my equation. So the equation then is, and I'm going to round those decimals to 2 places. So it's going to be Y equals, let's say, 2.95 x squared minus 38.01 x, and then plus 123.71. Now I want to approximate the number of skis sold in November. And remember that the months are being given as a number, and the months are my independent axis. So it's going to be the X value is equal to 11 here. So if I want to approximate where X is 11, that's another one where I'm going to need to just drag my cursor along the graph. And if I drag my cursor along the graph until I get to about X is 11, I see that the number of skis sold should have been approximately 62.29 pairs of skis, right? Not skis, but 62.29 pairs of skis. So 62.29 pairs of skis. And then in what month were the fewest skis sold? And again, I didn't click on the minimum before I screenshotted. So if you were to click on the minimum here, like, I know that your temptation is just going to want to be to talk about August, but let's see what the minimum point is on the graph. And if you click there, you should see 6.447 and 1.191, and it looks 1.191 Applebacher. And it looks like there were actually fewer skis sold in month 6, right? August was 2, and this time it was 1. And so you're going to want to take that 6th month, which is June. And so that's going to be my answer to that third question, is going to be June. June, or X equals 6. So now another question that you could be asked is, if I give you the regression graph and ask you to choose the most likely equation for that graph. So for example, in number 8, and I'm going to change screens. Hang on a second. So in number 8, let's say that you're given this regression graph. And I hope that you can see that this is more or less a parabola. It would be best represented by a curve that's an x squared curve and not a straight line. And what you kind of want to do is give yourself a feel for, well, I think that the graph would look kind of like this-ish. And it can definitely be ish. The equations, it would be a multiple choice question, and the equations you would be given would definitely be questions or equations that that are very different from each other. There's not going to be minute differences between them. And then I'm going to kind of say to myself, okay, well, it looks like the minimum is, let's say, 5, 6, 7, 8-ish, 8.5, let's say, 8.5, and let's say that the y value of that, if I go over to here, is maybe 20-ish, and that's all ish, right? But you see that there would be no x-intercepts here, right? It doesn't touch the x-axis anywhere, and the y-intercept would be way, way, way high. And so then what I'm going to do is take each of the graphs that I'm given in my multiple choices. So this here would be A, B, C, and D. And I'm just going to type each of them in one at a time and use process of elimination to choose which of those graphs would match the regression. And so the first thing I see in letter A is that it opens down, and the graph that we're given, the regression, opens up. And since A opens down, then it can't be A. So I'll cross out A. B very clearly has 2 x-intercepts, and the graph has no x-intercepts. So I'm going to cross out B because it has 2 x-intercepts. Now, C is looking like a good candidate. So I'm going to save that for a second and go over to choice D, which also has x-intercepts. And so I'm going to cross out choice D as well, and I'm going to answer choice C. So as I said, I'm going to choose choice C, and then here you're going to explain your process. And I'm not going to walk you through that. You can just explain what we just did. So here, explain your process. And please don't write this on your test review guide, explain your process. Actually, explain it. So the third part of your test is going to be systems of nonlinear equations, which, remember, means, and let me kind of give you a little bit of a definition here. Systems of equations means more than one equation at a time. In nonlinear, for our purposes, we're going to be talking about both linear and quadratic. So the fact that, I can't write and talk at the same time apparently, the fact that we're going to be doing some equations in each set that are not linear, we call the whole topic nonlinear systems. So the main idea is this. If you have a system of equations, the solution is where the graphs intersect. So here, you want to look for intersections between the two functions that are being graphed. So for example, here, your solutions or intersections are these 2 points. And you can be asked for the x and y values of those 2 points if I say to you, what are the solutions? But in this question, it's just asking you for how many solutions and asks you to circle them. So it's those 2 points, and so there's 2 solutions. In this next graph, there's no place where the 2 graphs overlap or intersect, and so this graph is going to have 0 solutions. In the third graph, once again, I see 2 places where the graphs intersect, so that's 2 solutions. And then in this last graph here, there's apparently only 1 solution. And then in the next question, I ask you to draw some systems of equations that have a certain number of solutions. And so for A, B, and C, notice that I asked you to do 1 line and 1 quadratic or 1 parabola. And then in letter D, you want to do 2 parabolas. Try not to give me the same exact graphs that I gave you in the in number 9. But one example here of no solutions might be if you have a parabola like this, and let's say a line like that, that would be no solutions. And then in letter B, something that has 1 solution, let's say that I have a parabola like this and a linear equation like that. The 1 solution would be right here. An example of a system with a parabola and a straight line that has 2 solutions could be something like, let's say this for the parabola, and then the line cuts across like that, and here are the 2 solutions. And then in the last example where it asks for 2 parabolas or 2 quadratics that have 2 systems or 2 solutions, I think the easiest thing to do would be to graph one opening up and an intersecting one opening down, and your 2 solutions would be here and here. Now remember that when we talk about specific solutions, not just circling them, but what are they, you would either be asked to give or to identify the ordered pairs that represent those solutions. So for example, in number 11, I see a solution right here, and I see a solution right there. This solution looks like it's the point -5, -7. The x value is -5. The y value is -7, right? -5, -7. And I see that right here. So let's just make sure that the other point matches. So the other point up here, my x value looks like it's 1, and my y value looks like it's 5. X value looks like 1, y value looks like 5, and that's this. So my answer for number 11 would be choice B. In number 12, it asks how many solutions exist. 2. Circle the solutions, I just did, and then write ordered pairs that represent the solutions. Decimals to 1 place in this case. So I'm going to say 2 solutions. I like to work from left to right along the x-axis, so I'm going to start with this solution up here. Let me pull my yellow. I'm going to start with this solution up here, and so to find the coordinates for that point, I want the x value and the y value. Let's call the y value 5. And then the x value, let's say, is negative 4.5. And so my answer for the first point would be negative 4.5, comma, positive 5. And then for the other point, I'll highlight that in green. And let me color coordinate what you're seeing here. And that, let's call the x value negative 0.5 here, about a negative 0.5, and negative 3 for the y value. So negative 0.5, comma, negative 3 would be the point that I highlighted with green. Now, the other way that we can ask these questions is to ask you to draw the graph and then write your solutions as ordered pairs. So let's say in number 13 that I ask you to graph this system. So you've got x squared plus 1 for your quadratic and x plus 1 for your linear. And when you type that into Desmos, it's going to look kind of like this. And you should see that your solutions would be 0, 1, and 1, 2. And you can click right on the places where the graphs intersect and get those values. So I know that my solutions here should be 0, 1, and 1, comma 2. And I want to verify that graphically. But remember that in order to draw the graph, you want to change the equation to a table. And you use the little gear and click on the table option for, that would be the quadratic, that's this, and then the linear, you have to do the same thing again then for the linear, and it'll give you this table. And if you need to add points, you can put your cursor below the last x value and just give yourself more points to graph. So when I graph, and I'm going to graph these real fast here for you. It's my other software that has the automatic line straightening. You can see that I kind of need it, but here you go. The solutions are here, 0, 1, and here, 1, comma 2. Then for number 14, the top equation is your linear equation. The bottom equation is your parabola or your quadratic. And they should look like this. When you get them into Desmos, you'll see that you have a solution at negative 5, negative 4, and negative 1, positive 4. I'm just going to already make a note of that. And when I get the tables for those two equations, I should see this for the linear and this for the quadratic. And I'll need to add some points, especially to the quadratic, to make sure that I know where the rest of the points that I have to graph are. So I'm just going to keep giving myself more more x values in the negative direction so that I can place those points accurately. I zoomed out at a weird degree here, but when you graph these, here's what you should see. And again, your solutions would be here, and this one is -1, 4, and this one is -5, -4. Now, for these last 4 problems, remember that on your test, there will be one problem that says specifically, solve this algebraically only. So you're going to get credit for an algebraic solution only. Of course, you can check your solution by graphing the equations, graphing the system, and seeing where they overlap, but I'll give you credit for having solved them and shown your algebraic solution. All 4 of these problems will require you to be able to factor. I didn't use any problems that have the quadratic formula or that require the quadratic formula. You can use it, of course, you'll get the correct answers if you prefer that over factoring, but all 4 of these would be shorter if you factor. The one that I'll put on the test will also be something that's factorable. So the first thing you want to do, remember, is check and see that the equations are all in y equals form. And so when you get to number 16, which I'll do in a minute, that one you're going to need to change both equations so that the y is by itself. Now, the approach here is, after you've checked to make sure that the equations are both in y equals form, that you take the stuff that's on the other side of the equal sign, whatever y is equal to, you take those 2 things and you set them equal to each other. And so I'm going to start here by writing x squared minus 5 equals 3x minus 7. Now notice that you have an equation that is just x's. And so you can solve this equation to get a value or 2 values for x. There might be 1 solution, there might be 2 solutions, but you'll get that value for x and then substitute that back into one of the equations to get your corresponding y values. So to start with here, I want to get all the terms of the whole equation on one side. So I'm going to subtract 3x from both sides, and I'll add 7 to both sides. So subtract 3x. There's no term that is like terms with the 3x, so I'm going to put that in between, and then add 7, and the 7 combines with the minus 5. So here I get x squared minus 3x plus 2, and then because everything over here canceled, the other side of the equation is equal to 0. Now, if I were you, I would pause the video, factor that expression. I won't go into factoring here. There's other videos about factoring. If you need to sit down with me and work on that, I'm available. But pause the video, factor that. And when you have factored it, you should get x minus 2 times x minus 1. And remember that when you have some multiplication problem, so for example here I have x minus 2 times x minus 1, when you have a multiplication problem that equals 0, you take each of the factors or each of the things multiplied and set each of those equal to 0 and then solve each of those. Now I have two x values, which means there's going to be two solutions. I can pick either equation, x squared minus 5 or 3x minus 7, but I have to substitute, I have to do this process twice. I have to substitute the first x value, get a y, substitute the second x value and get a y. So I am going to pick the linear one just because I think that's a little bit easier. So y equals 3x minus 7. And my first x value was positive 2. I'm going to replace this x with a positive 2 and simplify that. So y equals 3 times 2 minus 7. Plug that into Desmos, and you should get y is equal to negative 1. I'm going to do that process again with the other x value that I got as an answer, 3x minus 7. I'm going to substitute the positive 1 for the x, so y equals 3 times 1 minus 7. And when you plug that into Desmos, you should get y equals negative 4. And so my solutions for this system are x then y, so 2 then negative 1, and x then y, 1 and negative 4. Those are my solutions for number 15. Now, we said that in number 16, you need to rewrite those two equations so that y is by itself. So the first thing that I'm going to do is for the first equation, and remember I like to number my equations, so equation 1 and equation 2, x squared plus y equals 6. I'm going to subtract x squared from both sides, so I get y equals negative x squared plus 6. You don't have to keep the 6 first or the x squared minus x squared first. It doesn't matter because eventually you'll reorder them. The next equation here, x minus y equals 14. I would start by adding, I like to keep my y positive, so I'm actually going to start by adding y to both sides. That may sound a little counterintuitive, x equals 14 plus y, and then subtract 14 from both sides. That just works best for how I see the problem, and it keeps my signs. I don't ever have to change a negative 1 to a positive 1, which ends up giving me room to make mistakes. So anyway, the two equations that you're going to set equal to each other are the negative x squared plus 6 and the x minus 14. So over here, I'm going to say negative x squared plus 6 is equal to x minus 14. And I'm going to rearrange the equation so that all the terms are on one side equal to 0. And personally, again, to avoid the negative x squared, I'm going to add x squared to both sides and subtract 6 from both sides. And notice that the 6 is like terms with the 14, but x squared doesn't have any like terms. You end up with the 0 over here, and then positive x squared plus x minus 20. And when you do that, if you don't like having the 0 on the left, I know some of you really avoid that, then that's fine, move it over to the right. You don't even have to write it again, you can just slap it on the right, if that's easier for your eyes. But then the next thing that you want to do is factor that expression. So again, I'm going to recommend that you pause the video, factor x squared plus x minus 20, and come on back. And you should have gotten x plus 5 times x minus 4 equals 0. And then you set each of the factors equal to 0. X plus 5 equals 0. X minus 4 equals 0. Solve those two equations. Pick one of your two equations, and you want to choose an equation that's in y equals form. And I'm going to choose that second one. To me, that makes the most sense, y equals x minus 14. And I'll substitute my two x values in. So y equals x minus 14, and I'll start by substituting the negative 5 minus 14 and put that into Desmos, and you should get y equals negative 19. You can tell I'm recording this video in my classroom because the guy upstairs is moving desks around. Y equals x minus 14 for the other solution. Y equals positive 4 minus 14, and that's going to be negative 10. And so your two solutions for this question are negative 5, negative 19, and 4, negative 10. So number 17, everything's given to you in y equals form. So again, I'm going to take the first equation and set it equal to the second equation. I have 4x plus 2 equals negative x squared plus 2. I want to get everything on one side, so the whole equation is set equal to 0. So plus x squared and minus 2. I'm going to add the x squared, but there's no like terms. And minus 2, which means that this thing right here is a little interesting because that becomes 0 just like that becomes 0. So really, this whole thing then ends up as positive x squared plus 4x. Those are the two things that don't become 0. Everything else becomes 0. And remember that when you're factoring, if you have a GCF or a greatest common factor, you factor that out first. So now I've got x times x plus 4 equals 0. When I say if you have a multiplication problem equal to 0, you take each thing multiplied. Well, that's this and this. You take those two things and set each of them equal to 0. So set x equal to 0, set x plus 4 equal to 0. X is 0, and x is negative 4. And let me just show you that here I subtracted 4. Okay. You don't have to do anything else to the x equals 0 part. You do have to then solve the x equals negative 4 part. And once again, I'm going to go back up to my original equations. Choose the one that's a little bit more straightforward, which to me is the first one, y equals 4x plus 2. And I'm going to substitute those two values into y equals 4x plus 2. I'm going to start with 0. Y equals 4 times 0 plus 2, so y equals 2. And then once again, y equals 4x plus 2. So y equals 4 times negative 4 plus 2. And in that case, you should get y equals negative 14. And so your two answers are 0, 2, and negative 4, negative 14. Finally, this last problem, again, you don't need to set anything equal to y. It's already in that form. And you want to take the two equations and set them equal to each other. So 3x plus 2 equals 2x squared. This may feel a little counterintuitive to you, but remember that I like to keep the coefficient on the x squared positive, or your a value positive. So I'm actually going to move the 3x and the 2 to the other side. And that way over here I get 0 equals 2x squared minus 3x minus 2. And again, if you would rather write 2x squared minus 3x minus 2 equals 0, you can do that. Go ahead and pause the video, factor that expression, and come back when you're ready. And you should have gotten 2x plus 1 times x minus 2 equals 0. Set both of those factors equal to 0. Solve both of those equations. Now I'm going to pick the linear equation to substitute into. You should get the same y values whether you choose the equation that I choose or you choose the other equation. And I'm going to choose the 3x plus 2 and substitute into that y equals 3x plus 2. And I'm going to substitute the negative 1/2. Type that into Desmos. You should get y equals negative 1/2 as well. And then for the other one, substitute in your value that your other x value that you got, which is 2. And you should get y equals 8. So your solutions here would be negative 1/2, negative 1/2, and 2, 8.